In this video, we're going to learn what process management means in operating systems. You'll understand how your computer runs many apps at the same time, how it keeps everything organized, and how it makes sure one app doesn't disturb another. We'll break it all down in a fun and simple way that's easy to follow, even if you're just starting to learn about computers. Imagine you're watching a YouTube video, downloading a game, chatting with your friend, and listening to music all at once. Sounds cool, right? But have you ever thought about how your computer handles so many things at the same time without crashing or getting confused? That's where process management comes in. It's a super important job that your operating system does every single second your computer is on. Let's start with something basic. What is a process? A process is just a program that is currently running. For example, when you open a game, it becomes a process. When you open your browser, that's another process. Even the small things like your calculator or your file manager are also processes when they're running. So process management means controlling all these running programs in a smart and organized way. The operating system, OS, is in charge of this. It decides which process gets to use the CPU, when it runs, how long it runs, and when to stop it. Just like a teacher who gives every student a turn to speak, the OS gives every process its fair share of time and resources. Your computer can only do one small task at a time on a single processor, but it switches between tasks so quickly, thousands of times every second, that it feels like it's doing everything at once. This is called multitasking, and it's possible because of process management. Let's look at some important things the OS does in process management. Please don't forget to subscribe to my channel and click on that like button if you like my video. Also click on that notification bell. Thank you. First, there is process creation. Every time you open an app, the operating system creates a process for it. It gives it a unique ID, memory space, and the tools it needs to run. Think of it like setting up a new desk in a classroom for each new student that joins. Next is process scheduling. Since there are many processes and only one CPU in most computers, the OS uses something called a scheduler. This scheduler decides which process runs next. It uses different rules or algorithms to make sure everything is fair and fast. Some processes may get more time because they are important. Others may wait their turn. Another big job is process execution. When it's a process's turn, the OS lets it run on the CPU. The process can do its work, like showing you a video, calculating something, or loading a web page. The OS keeps an eye on it the whole time, and then comes process suspension or termination. When a process finishes its job or is no longer needed, the OS removes it and frees up memory and resources. This keeps the system clean and ready for new tasks. There is also something called context switching. Let's say process A is running, but now it's time for process B. The OS quickly saves the current state of process A, like a bookmark, so it can come back to it later. Then it loads the saved state of process B and starts it. This switch happens so fast that users never notice it. All processes go through different states. A process can be new, just created, ready, waiting to run, running, currently using the CPU, waiting, paused, and waiting for something like data from the internet, terminated, finished, and closed. The OS keeps track of each process using something called a process control block, PCB. This is like a report card or file for every process. It stores the process ID, its current state, how much memory it's using, what files it's using, and other details. This helps the OS manage and switch between processes smoothly. Apart from this, I want to tell you that we offer multiple services on our website, and IT-related courses are one of them. Make sure to check out our website and stay tuned. I'm mentioning the link in the description box. Now let's talk about process priority. Not all processes are equal. Some are more important. For example, a system update might have higher priority than your music player. The OS uses priority levels to decide which process should go first or get more CPU time. If a process is using too much time and slowing down others, the OS can lower its priority. Sometimes processes need to work together. For example, when you download a file, one process might get the data while another saves it. These processes share data and work as a team, but they have to be careful. If two processes try to change the same file at the same time, things can break. That's why the OS also handles process synchronization. It makes sure processes work together safely without messing things up. Another important part is inter-process communication, IPC. This is how processes send messages or share information with each other. They use methods like signals, shared memory, or message queues. The OS controls this communication to make sure it's safe and organized. Let's also talk about zombie and orphan processes. These sound scary, but they're just leftover processes. A zombie process is a process that has finished running but hasn't been fully removed from the system. It's like a ghost hanging around. An orphan process is a program that's still running, but its parent process, the one that started it, is no longer around. In computers, many programs start other programs. The one that starts another is called the parent, and the one that gets started is called the child. For example, if you're using a drawing app and that app opens a tool to choose colors, like a color picker window, the main drawing app is the parent, and the color picker is the child. Now, let's say the main drawing app suddenly crashes or you force close it, but the color picker window stays open. That little color picker is now an orphan process. Its parent is gone, but it's still running. The OS finds these processes and takes care of them, so they don't cause problems. So why is process management important? Without it, your computer wouldn't be able to run more than one app at a time. It would freeze, crash, or work super slowly. Process management keeps everything running smoothly, makes sure no app hogs all the resources, and gives users a fast and stable experience. In modern systems, process management is even more advanced. Some computers have multiple CPUs or CPU cores. The OS can run different processes on different cores at the same time. This is called parallel processing, and it makes things even faster. Still, the OS must manage which process runs where and for how long. Even on smartphones, process management is working all the time. When you switch between apps, get a call, or play music in the background, your phone's OS is managing all those processes efficiently. To make this all happen, operating systems use special scheduling algorithms like first come, first served, FCFS. The process that comes first runs first, shortest job. Next, SJN. The shortest process runs first. Round robin, each process gets a small time slot in a rotating order. Priority. Scheduling. Processes with higher priority run first. Each algorithm has its pros and cons. Some are better for fast response times, while others for fairness or efficiency. The OS picks the right one based on what the system needs. In short, process management is how your computer or phone keeps everything running smoothly, safely, and in order. It's like a smart manager in charge of a busy office, making sure every program gets what it needs and everything works together. Now that you understand process management, you've unlocked another powerful concept in how computers work. From running your favorite games to handling background updates, this is the magic behind the scenes. Keep exploring. You're getting closer to becoming a computer pro. I'll see you in the next video, and let's keep learning together.